Hi, welcome to America Reads Fun Learning Activities. We're college students who create learning activities for kids. Our fun activities are focused on reading, writing, and math. Thank you for joining us to learn today. My name is Rebecca. In today's activity, we'll be learning how to solve a system of two linear equations. Have you ever heard of any of these types of riddles? There are cows and chickens on a farm. Among the animals, you have 16 heads and 44 legs. How many cows and chickens are on the farm? What about this one? At two-digit numbers, digits add to 7, and when the digits are flipped, the number is increased by 27. What is the number? At first, these problems may sound really hard to answer, but it can actually be pretty simple to solve them if you know how to solve a system of linear equations. What are linear equations? Well, a system of equations is a collection of two or more equations that share similar variables. If you were to plot these equations on a graph, they would likely intersect. Now, a linear equation is an equation that has two or more variables, and the only thing that's in the equation is variables and constants that you add to them, and coefficients on the variables. There's nothing like x squared, or sine of x, or anything weird like that. It's just coefficients and variables. Linear equations can have any type of variable. You can call them x or y, you can call them t or s, you can call them whatever you want, as long as you're consistent. A system of linear equations is a system of equations where all the equations are linear. So, similar to before, you're going to have the same variables in each equation of the system. However, you cannot have anything like x squared, or anything that gets really complicated. So, what does it mean to solve a system of equations? Mathematically, it means that you're finding the point where the equations are equal. If you're given, say, these two equations, you can set them equal to each other because y equals y, so therefore 2x plus 1 will equal negative x over 4 plus 4. Graphically, the solution to a system of equations is the point where the equations intersect. If you were to plot these two equations on a graph, it would look like this, and you could find the spot where they intersect. And if it happened to fall on a specific line on the coordinate plane, then you could figure out the solutions just from that. There are three main ways to solve a system of linear equations. The first method I've briefly mentioned. It's that of graphing. So if you were, say, given these two equations, you could graph them on a plane, and you could find the spot where they intersect. However, this doesn't always work. If you look at this graph, you can see that the point where they intersect is not actually on a specific integer number, which means it's hard to tell what x and y they intersect at. To get around this, we have two other methods of solving linear equations. The first one is called substitution. You want to rearrange one of your equations to solve for one of your variables, for example, y. In this case, the equation's already rearranged just fine, so we don't have to do anything. We can set the y in this equation equal to the y in the other equation, and by putting them together, we end up with just one equation with one variable, and we can solve for x, and then plug it back in to find y. The final method for solving a system of equations is elimination. Basically what you do is you take your two equations, and you want to add them together. But in doing so, you want to make sure that one of the variables equals 0. To do this, you multiply the equation by a coefficient. In this case, it would be negative 1, because y minus y equals 0. In this way, you're eliminating the y, and once again, you end up with an equation where you can just solve for x. Let's go through an example of graphing to solve a system of equations. Say you're given these two equations. The first step to graphing an equation in this y equals mx plus b form is to find the y-intercept. This is just the number that's standing by itself with no variables. In this case, it's 1. So our first point that we have for this first equation is at 0, 1. Next, we need to know the slope. In this form, y equals mx plus b, the slope is the coefficient in front of the x. This is 2. Geometrically, the slope of a line is equivalent to how much it goes up divided by how much it goes to the side. In this case, since the slope is just 2, it rises 2 for every 1 that it goes to the right. So here we can draw it going up 2 over 1, up 2 over 1. Similarly, working backwards, it'll also go down 2 and over to the left 1. You can connect the dots and make a line. Next we repeat this with the other equation. We start with the y-intercept, so the first point is at 0, 4. The slope of this one is negative 1 over 1, which means that for every 1 that it goes to the right, it goes down 1. We can graph this, and then connect the dots. We can then write down the coordinate where they intersect, in the form of x, y. The x-coordinate is 1, and the y-coordinate is 3. If we wanted to write it in the form of x equals 1 and y equals 3, we could do that, and that's our solution. Now let's try an example for substitution. We're given these two equations, and let's say we try to graph them really quick, using the same method as before. However, when we graph them we realize there's no clear spot where they intersect. It's really hard to tell when they're in between integers. So instead of graphing, let's try something else. The equation is already arranged in a way so that y equals something for both of them. Since we know that y equals y, we can set the two sides of the equations equal to each other, since they equal the same number. This makes substitution a lot easier, since we don't have to rearrange our equation. What we can do is that because both equations equal y, we can simply set the right-hand side of both equations equal to each other. This gets rid of the y component, and now we're left with an equation that only has x and some other numbers in it. So our equation is 2x plus 1 equals negative x over 4 plus 4. Let's try solving this. Our first step is to move the 1 over to the other side, so we subtract 1 from both sides of the equation. This gives us the equation 2x equals x over 4 plus 3. Now we want to move the x over 4 to the other side, so we add plus x over 4 to both sides of the equation. Now we have 2x plus x over 4 equals 3. Now how do we get 2x plus x over 4 into a single coefficient? Well, we're just adding fractions, and we know that 2 is equal to 8 over 4. If we add 8 over 4 to 1 over 4, we get 9 over 4, which means that our equation is now 9 over 4 times x equals 3. We're almost done. Now we need to multiply this fraction over to the other side. First what we do is we multiply both sides by 4 to get rid of the bottom part of the fraction. This gives us 9x equals 12. Now we divide both sides by 9, giving us x equals 12 over 9, which is equal to 4 over 3. With this information, we can plug our x into one of our equations to find y. It doesn't matter which one you choose. So we have the equation y equals 2x plus 1. We plug in our x equals 4 over 3 to get y equals 2 times 4 over 3 plus 1, which gives us 8 over 3 plus 1, which gives us 11 over 3. Therefore, our answer is x equals 4 over 3 and y equals 11 over 3. You'll see that we have another system of equations next to this one. If you look carefully, you'll realize that they're actually the same two equations, just that the second one has been rearranged so that x equals negative 4y plus 16, as opposed to y equals negative x over 4 plus 4. We can do the same thing as we did before, except we will substitute the x in instead of the y. I'll run through this one a bit quicker since we've already solved the problem. But you see, by the end, we get the same answer for y, and when we plug it into our other equation, we get the same answer for x as well. Finally, let's try an elimination problem. We're given these two equations, y equals 2x plus 1 and 2y equals 6x plus 7. What we can do with elimination is line these two equations up in a row and try to add them in a way that'll make one of the variables go away. So if we line up our y's, we'll see that if we simply add these two equations, we'll end up with 3y. We don't want 3y, we want 0y. So what can we multiply y by so that that plus 2y is equal to 0y? Well, that would be negative 2, because negative 2y plus 2y is equal to 0. So we then multiply the first equation by this negative 2. It distributes out to form the equation 2y equals negative 4x minus 2. We move the other equation over, and we just add the components. Now we have a simple equation, and we can solve for x. We subtract 5 from both sides, and then divide both sides by 2. to get x equals negative 5 over 2. We can then take our equation y equals 2x plus 1 and plug in negative 5 over 2 for x, which gives us y equals negative 4. Wow, that was a lot of work. I want to make sure that we did everything right. An easy way to check to see if your answer is correct is to plug your x and y into both of your equations. So let's try the first one, y equals 2x plus 1. Well, our y equals negative 4, and our x equals negative 5 over 2. If we solve this, we see that we get negative 4 equals negative 4, which is true. Let's try the next one. 2y equals 6x plus 7. This is equal to 2 times negative 4 equals 6 times negative 5 over 2 plus 7. When we simplify the equation, we find out that negative 8 equals negative 8, which is also true. This means that our answers are correct. Here are two examples I want you to try on your own. You can choose any method to solve them, but then you should use another method to double check your answers. I'll give you a minute to pause the video, and when you come back, I'll show you my work and the answers. Here's the work for the 3 different methods of solving these systems of equations. If your answers are different from mine, you should go through your work and compare it to mine, and see where our work is different. There's a good chance that that's where things went wrong. If you made a mistake, that's okay. Make sure to note where you went wrong so that next time you won't make the same mistake again. Now that we know how to solve a system of linear equations, let's go back to those first problems at the beginning of the video and see if we can solve them. So the first one, we have 16 heads and 44 legs. Well, what do we know? We know that a cow has 1 head and 4 legs, and we know that a chicken has 1 head and 2 legs. Using this information, we can figure out how many of each animal are on the farm by setting up a system of equations. First, we need to make 2 variables. We'll call x our number of cows, and y will be our number of chickens. The first equation we'll set up will have to do with the heads on the farm. First, we have 1 head times x number of cows plus 1 head times y number of chickens, and that equals the total number of heads, which is 16. Our second equation will have to do with the legs. We have 4 legs times x number of cows plus 2 legs times x number of chickens, and that equals 44 legs. Let's rewrite this equation more simply. We have x plus y equals 16, and 4x plus 2y equals 44. I want you to see if you can solve this yourself. Pause the video now and try using any method you want to solve it, although I'll recommend substitution or elimination. Here's the work for a method of substitution. I first found x from the first equation by turning it into 16 minus y. I then substituted that x into the second equation, solved for y, and plugged y in to solve for x. I got 10 chickens and 6 cows. Here's the work for elimination. I lined up the 2 equations, multiplied the first one by negative 4 so that the x's will cancel. In the end, I got an equation to solve for y, and I used that y to solve for x. Again, I got 10 chickens and 6 cows. Let's try the other problem. A 2-digit digits add to 7, and when the digits are flipped, the numbers increase by 27. What's the number? So what this means is that you have a 2-digit number, and when you take the individual components, they'll add up to 7. Now if you flip the digits around, then the final number's value is actually greater than the original by 27. So how can we turn this into a system of linear equations? Let's use the variables x and y to represent each digit of the number. We know that the 2 digits added together equals 7, so x plus y equals 7. We can also write out the actual number in terms of x and y by taking x, which would be the tens place, multiplying it by 10 and adding it to y times 1, which is the number in the ones place. This gives us our original number. However, we know that when it's flipped around, we get a different number. So when we flip the digits, we actually have y times 10 plus x times 1. This is equal to our original value plus 27. We can rewrite the equations like this. I encourage you to stop the video right now and try to solve it yourself. Have you finished? The answer is x equals 2 and y equals 5. This means that the original number was 25. Great job! Now you know 3 different ways to solve a system of equations. If you want more practice, be sure to go through the America Reads activity sheet that comes with this video. Thank you for learning with us today. I hope you come back and learn some more. Please comment if you have any questions, like and subscribe to our channel. And we'll be back with more videos. Bye!